Hello learners, welcome back to my channel Shraddha's Physics. In this part we will see the shortest distance between the 2 points in a plane. It will be a straight line. Now let us draw the two lines, that is this one is suppose my y-axis and this one is suppose the x-axis, and here there are 2 points, that is A and B, and here we have to show that if I will connect this point, this one is A point and this is your B, this is your x-axis and this one is your y-axis. We have to prove that this AB, the line joining these two point, it will be the shortest distance. Let me draw. This is the any neighboring distance. You can, this dotted one, it may be any neighboring path we can say. Now let us consider, so suppose this point is your x1 y1. Let me write, this point A is your x1 and y1. These are the coordinate at the point A, and the B coordinate is suppose x2 and y2. That is, it travels x2 distance. For the B point it travels x2 distance. If I will draw a perpendicular, so this distance is x2, and if I will draw a perpendicular, this distance is suppose y2, and so on. Okay, so now let us write, let us consider A, that is x1 comma y1, and B, that is x2 comma y2 at the 2 points in xy plane. So these 2 points are situated at the xy plane. So now if I consider the ds, so ds is the elementary length we can say. So this path is suppose P and this path is suppose P prime. So let ds equal to the elementary length of any curve, the elementary length of any curve, that is suppose let me write A P prime B passing through A and B point. Okay, so now we can write this ds distance. So suppose any path ds square, it can be written as, we know, this is equal to dx square plus dy square. We can write like this. Okay, so this is ds square can be written as ds square plus dy square, and now if I take common this ds square term, so then this will be 1 plus this will be dy by dx whole square. This is just like this. Okay, I can write like this. Now this expression, if I will take ds, now we can write ds, that is equal to, if I will take the square root of this all, then this will be dx into the square root of 1 plus y prime, because you know y prime equal to, since y prime equal to dy by dx. Okay, so simply substituting this value, I will get this is 1 plus y prime square. ds value equal to this much. Now we have to calculate the total length of the curve from the point A to B. So to calculate the total length of the curve, now we have to integrate. So this ds is the any small length, if I will consider this small length, any small length if I will consider, that is your ds. So to calculate the total length, simply I have to integrate this from A to B. So now let us do the same. So now the total length of the curve from point A to B is, we can write, so S equal to simply integration over, this is from A to B, root over of 1 plus y prime square into dx. Okay, so now if you can remember, we can write simply this function, any you can check, you can choose this ds or df, whatever. So simply here we have considered this displacement as ds. So here after integrating for the total length, we will get s equal to this much. And also we know this s, or simply if I write I, so this I equal to the integration from f dx, where f is the function of y prime and x. Now here you can say, see, this function is the y prime, this is the function of y prime. So simply if you will compare these two equation, now we can simply substitute the value of the Euler-Lagrangian equation if I will compare. So let me write, if I will choose, so let me write s equal to the length of the curve will be minimum, the length of the curve will be minimum when delta s value equal to 0, and we know this value equal to extremum. Extremum means it may be maximum value or it may be minimum. So if I will consider the length of the curve will be minimum, so we can consider when this delta s equal to 0, then this is the s equal to the minimum path. So now that is f means f equal to, it is here 1 plus y prime square. Okay, that is f equal to this much. So satisfy Euler-Lagrangian equation. It should satisfy Euler-Lagrangian equation. Now if I will write the Euler-Lagrangian equation, so that is, let me write it here. So this is d by dx of dou f by dou y prime minus dou f by dou y, that is equal to 0. Okay. Now if we will calculate, f equal to 1 plus y prime square and root over, and if we will take the derivative with respect, this is the partial derivative with respect to y, since this term doesn't contain any y term, so this term goes to 0, dou f by dou y equal to 0. And now if we will take the derivative with respect to the y prime, so here the function, it contains y prime term, so I can calculate for, this is your dou by dou y prime of root over 1 plus y prime square. So this is 1 plus y prime square, means this is 1 plus y prime square power 1 by 2. Now simply if we will take the square root of this expression, then this will be equal to 1 by 2 root 1 plus y prime square, and again into dou by dou y prime of, let me write dou by dou y prime of, this is your y prime square, and the y prime square derivative will be 2y prime. So the 2 get cancelled, then this will be y prime divided by the root over of 1 plus y prime square. Okay. Now if I substitute all these values here, so now this equation will becomes, so this will be, or we can write, this is d by dx of the value of dou f by dou y prime is this much. So if I will substitute, this will be y prime divided by root over of 1 plus y prime square minus this value dou f by dou y equal to 0. So I can directly write this equal to 0. Okay. Now you can see this expression, that is d by dx of this much term equal to 0. Or simply we can write this term is your constant, that is y prime divided by root over of 1 plus y prime square, that is equal to constant. Since this term is constant, so we can take it as suppose c. Now if I solve this equation, now this is becomes, or we can write, this is y prime square equal to c square whole into this root over square, means this is 1 plus y prime square. Or if I will take this y prime square to the left hand side, then this will be, or taking y prime square common, this will be 1 minus, this will be c square, that is equal to c square. Okay. Or this can again written as y prime will be equal to c square divided by 1 minus c square whole root over. Or this is your total constant a, we can say this is your constant. Suppose a is your constant. Since y prime equal to this much, or we can write y prime means dy by dx, dy by dx now equal to a. Since dy by dx equal to a, or we can write dy will be equal to a into dx. Now if I will integrate both sides, since a is constant taken outside of the integration, and now this will equal to y equal to ax plus any other constant, suppose b. So now you can see this equation, it will give a, this is your equation of straight line. This is your equation of straight line, where a and b are the integration constant, where a and b are called the integration constant. So now you see what we have considered and what we get, that is we have considered the neighboring path of this. So here you can see we have considered the neighboring path, that is a p prime b, and that after if I will take d square equal to d square plus dy square, from that relation if you have calculate, so let me show you, this is your the integration value, that is if you will integrate 1 plus y prime square root over dx, and if you compare this with the integration that is equal to f dx, where it has the extremum value. So in that case if you will apply, since this function, this f is the function of the coordinate, position coordinate, and y prime and x, so in that case we can apply the Euler-Lagrangian equation, and after substituting all the values and after calculation we will get y equal to x plus b, or you can see the relation between y and x, it will give the equation of the straight line. Okay, so from this we can conclude that, so let me write, so the shortest distance between any two points in a plane is a straight line. It is a straight line. Okay. Now what about the integration constant? So the integration constant can be determined by, it can be determined by the condition of straight line passes through a, that is x1 comma y1, and b x2 comma y2. So from this condition you can calculate the integration constant, because the point is exactly not given, that is this x1 point and y1 point, that is maybe 2, 5, 3, 4, whatever it may be. So if you put all these values, so that you can calculate the integration constant value. So in this way you can show that you can prove the shortest distance between any two point, that is in a the 2 point in a plane, it will be a straight line. So this is all for today. Thank you all.